Yes, good morning, everybody. I don't know if you can hear me.
Yes, sir, you're audible.
All right, okay, good morning. Yes,
Okay.
okay.
Good afternoon, one
Uh,
and all. Yes, sir. Good
yes,
afternoon, one and all. Participating in the fourth session of the International STTP on DATASCULPT, hosted by Bengal College of Engineering and Technology, Durgapur. The chairperson for this session will be HOD AIML Assistant Professor Mr. Tapas Pal. The resource person for this session will be Dr. Tashos, Institute for Cognitive Systems, London, South Bank University. Professor Tashos is a leading researcher and expert in the field of smart internet technologies for smart cities, healthcare, and smart agriculture. He is the leader of the smart internet technologies at London South Bank University. Professor Tashos has been the principal investigator, co-investigator, and focal person of more than 20 internationally R&D and capacity training projects in the area of 4G and 5G networking technologies and multimedia networking solutions. Professor Tasha's research interest lies in the field of 5G networking technology, programmable networks, V2X communication, and cybersecurity for the smart internet system. Now, I would request Professor Dr. Tashos to continue the session. So please.
yes, all right. Yes, good morning, everybody. I'm sure. First of all, I would like to thank you for this nice invitation. Um, what I'm going to talk today is about towards AI in the edge, the road ahead. And basically, my presentation is about how AI can be used on 5G and 6G, in particularly what we call edge cloud. So you will see there is a lot of, let's say, synergy between AI and machine learning, yeah, for these technologies. Yeah, so my presentation, first of all, is about to discuss about what is the edge, the role of AI, how it can be used AI. Of course, I'm going to discuss with you some research questions that we have investigated. We have done some experiments and we will see also some theoretical analysis, and I have also some references. And the road ahead is about how we can move forwards with respect to what is called 6G. Because I would like to have have a kind of interaction session, so probably I will have some breaks at some points during the presentation in order to answer some questions. Right, I don't want to monopolize the entire time for that. So, as mentioned, I'm leading a research team at London South Bank University. It's called Sud Lab, Smart Internet Technologies. We have been investigating, carrying research on different aspects. And as you will see later on, AI and machine learning plays an important role when we want to design and trying to solve problems in the area of 5G and 6G as well. So first of all, let's see. Uh, let's start. What is 5G about? Because we have been discussing about 5G, but what is 5G about? 5G, as has been defined by ITU, is under three pillars. One pillar is related to what is called enhanced mobile broadband, dealing with applications that are demanding in terms of capacity and also in terms of latency as well. Applications related to 4K, 8K video streaming, AR, VR, cloud gaming, just a few of the examples of potential applications. One other important area is what is called ultra reliable low latency, when we have very strict of the delay. Typical examples lies in the area of industrial automation, remote manufacturing, surgery, and there are already use cases that have been demonstrated through some of the international projects at the global level. And finally, a third pillar is related to massive machine type of communication related to use cases associated with buildings, energies, agriculture. So basically, it's 5G is not about building a new radio system, but we have a revolutionary way how we are going to design the architecture. A key element in that lies in the area of agile and programmability. So we are introducing the DevOps concept in the new type of 5G architecture. It's not only about connecting people, but also we have use case scenarios like, for example, connecting objects to facilitate machine to machine communication. So we have, of course, from flexibility point of view, open kind of architecture. At the same time, we need to take into consideration other important aspects with respect to scalability, security, and reliability. Um, this is also related to the evolution of the industry. So we are moving towards what is called Industry 5.0. Industry 4.0 that was introduced a few years back was related to IoT, objects in different environments, the introduction of course, cloud computing to support multi-tenancy. Now the Industry 5.0 needs new capabilities with respect to the machine learning. And of course, we have seen across different types of deep learning models like and technologies like generative AI, discriminative AI, such a few of the examples. My talk today is going to we are going to discuss mainly an important pillar in this architecture, which is called as cloud computing. As cloud computing in general refers to the use of virtualization technologies to facilitate different services, either starting from the infrastructure level, moving towards to the platform as a service model, and finally to the service model. But what is basically edge cloud computing? Edge cloud computing is mainly pushing the cloud towards the edge. When we refer to edge, we refer to the case when we have users that can generate data, user or if you like devices. And here the example, when we refer to devices, that can be IoT devices, it can be a mobile network where a user is connected, and it can be a gateway in an enterprise environment. On the right side, you will see there are a lot of different standardization bodies that dealing with the standards, because the term edge cloud computing appears with a different term. We've got the European Telecommunication Standard Institute. They have introduced the concept of MEC. MEC stands for Multi-Access Edge Cloud Computing. We've got so mainly the focus of FETSI is basically how you can deploy this cloud of infrastructure in usually in telecommunication network. We've got Open Edge Computing initiative in the US, which is mainly dealing with APIs associated with the deployment of services on the edge. And we've got a couple of different IoT fora like Open Fog or Industrial Internet Consortium. So basically, the angle of edge from the IoT perspective with the different scenarios. So there are a lot of different standardization organizations, but also this highlights the importance of edge, how the technology moves forward. And according to some, let's say, marketing reports, I have given here a resource from McKinsey, which is a huge consulting company. We expect at some point by 2025, the market for edge cloud can reach to between 175 up to 215 billion of dollars. So there's a lot of, let's say, there's a lot of potential. And you will see here from this report, I have grasped an interesting figure demonstrating the different verticals, how where edge cloud computing can be deployed. We have verticals or use cases, if you like, related to travel, to cross, to retail, to media, so to public sector, to energy, to to healthcare. So there are a lot of, let's say, use cases for that. If you would like to see what will be the value, right, from the business perspective, so we have the how we can build this kind of environment, this kind of edge infrastructure, and what will be the characteristics. It's an environment where you have limited cloud resources, unlike the well-known hyperscalers, where there are in practice endless number of resources, computing resources. In an edge environment, the resources are rather limited. So, and in some cases, we refer to resource constrained devices. So the computing capabilities are rather limited. Of course, this kind of devices um, can be deployed in a distributed manner in your infrastructure. And then on the top, you may have the orchestration. I have a slide regarding what is an orchestration. So, and finally, we can have different applications that you can run. And I have also in my presentation later on, we have, I can give you, let's say, some of the research challenges associated with a very, let's say, demanding application like the surveillance, or if you like, anything related to video analytics. So we've got a terminology which is called edge to cloud continuum. That means you may have an environment, you may deploy all this edge infrastructure, and then this kind of deployment model, depending on, first of all, the capacity, the volatile also in terms of the resources, and how close is this infrastructure to an end user. So when we deal with fog nodes, right, which is also a part of the Net Cloud infrastructure, we are referring mainly to a device which is maybe close to some IoT devices. And then as we're moving towards the network part, you'll see the MEC node that can be located or if you like co-located with a base station, all right? And then moving towards the to the right, we can may have the central cloud. So at the end of the day, a key challenge is in a kind of this kind of infrastructure, the decisions that somebody needs to take with respect to what kind of tasks you can offload to a fog node versus what kind of tasks you can or what kind of service you can have in an MEC node, and finally, what can be needs to be executed. At the end of the day, it's good to discuss about the rationale why we need to do that. First of all, there are applications that are real-time applications when we need to process data, and sometimes this data can be quite large, depending, of course, what kind of data is it. For example, if you have video, we are talking about a large amount of data. And the key characteristics for that is to process this data without any latency, without any delay. Because of course, if you want to do that centrally, all right, in a hyperscaler, you may not have any issues with the cloud resources, the computing resources, but on the other hand, you may experience this latency in certain applications. You need a fast response to that. So the lag to respond to data spikes can be eliminated by deploying this kind of infrastructure. Of course, in some cases, we don't have necessarily the deployment of 5G, or if you like, you may experiencing issues with the internet bandwidth. So if we process this large amount of data near to the source, we are alleviating all these variations to the internet bandwidth. All right. And of course, another aspect is in some cases the security, because in certain places, for example, in Europe, we have something called the GDPR. So there is a lot of concern about privacy of information when information associated with certain applications needs to be sent to a hyperscaler. So there is a lot of concern. So if we need to deal with sensitive data, this can be considered as a kind of a private kind of infrastructure. What is important to take in considerations also, this is an important aspect in edge cloud computing, is to take in consideration the evolution on virtualization technologies, which is the key pillar in order to deploy all these applications. If we want to see the evolution of that, we started a few years back with what we call a virtual machine. So a virtual machine is basically um, the opportunity to host a guest operating system across any kind of hardware. In order to facilitate that, you need something which is called hypervisor. All right, and we have two types of hypervisors, type 1 and type 2. Type 1 means that you can host the hypervisor just above the hardware in order to reduce the overhead, and of course also can have also security, more security robustness, or can have type 2 hypervisors when you can deploy the hypervisor on top of the existing operating system. One of the problems of the of the virtual machines is the associated computing overhead footprint. Especially this is important for resource constrained devices like the edge. Excuse me. So the next evolution is what we call containers. So container is basically a wrapper, so we can let's say install the functions by building a container edging, and then on the top you have the associated binaries. And another evolution is you can have the unikernels, which is something which is a bit lower level virtualization approach that you don't need necessarily an operating system. So a key aspect on the edge cloud environment is how to be able to reduce the computing overhead associated with virtualization, because you would like, let's say, first of all, to host many applications, and in the same time you would like to have several tenants. This is the terminology from cloud computing. Of course, when you do that, you have a flexibility, but there are some research challenges. One aspect is in this kind of environment, a resource constrained environment, you may have failures or outages. So first of all is how we can identify these failures. This is the first question. The second question is how to use AI and machine learning, and what will be the impact of such failures in a multi-tenancy. That means I have not only one user, but I may have several users depending on the capabilities. So how to cope with these failures? So in order to do that, first of all, we need to understand that a key pillar in this environment is what is called orchestration. The orchestration is a central point when you can manage all these nodes, the edge nodes. And the whole idea is, first of all, to do the scheduling of the tasks and the tasks associated with services as well. So a key aspect is, and just an example of typical orchestrations. In our days, we may have Kubernetes, or you may have other orchestrations. For example, Etsy has developed its own orchestration, as I mentioned, something related more to the telco world, which is called Mano. So at the moment, there are already existing approaches that they make some decisions about the allocation of the tasks. Now, the whole idea here is, as I mentioned, is how I can use a kind of machine learning, or if you like, deep learning. So here the whole idea is, first of all, in this kind of environment, what somebody can do is you can have a kind of monitoring tool, and already even available open source tools that we can measure the status of each of the edge device. So in this example, you'll see here this figure that I have different instances, edge devices, and each device you can we can run several VNFs. As I said, the this task allocation can be carried out by the orchestration. Now, what we can do in this kind of environment, we can capture, as I said, the monitoring status of each of the instance, and then this kind of information we can present that as a time series format, and then we can use deep learning in order, first of all, to predict when about an instance may have a kind of a stressing problem, or it can be a failure. All right. So what we can do in this case, we can do what is called migration. Migration is the case when I want to transfer, all right, a VNF from one let's say, edge instance device to another one. And how this can be done? This can be done through the transport network. So, what we need in practice, we have in cloud computing something which is called a snapshot. Snapshot is we can get a snapshot of the existing VNF as it runs, and then what we can do, we can use the existing infrastructure where these devices can communicate to each other. Uh, this is something that even is not been defined on the standards, so it's up to different technology providers how you can interconnect the different devices, and you can use the transport network to transfer that. Once you transfer that, then you can, let's say, initiate. Now, one of the problems also when you do this process, which is called migration, all right, and we're talking about live migration because you have been already running a service, is how to protect this process because um, during this transfer that I just mentioned, we may have a problem of man in the middle attack. So in this example, I'm just, or if you like, what we have investigated is the possibility to use blockchain because it's a mutable entry, and then we can record basically migration metadata information on a blockchain. And then we see on the right some of our research papers that deals with what the problem that I have just presented. If we move also how to do that in an automatic fashion. So we'll see here a graph that shows information that we have recorded in experiment using some Raspberry Pis. So in these Raspberry Pis, we collect some information. So information that we have collected is related to CPU utilization, memory utilization, and bandwidth utilization. So we have values, you'll see A, B, C. So the whole idea here is how to combine that. So how you can have a kind of utility function. And this utility, the whole idea is how to be able to combine all these values. In our case, we call this value Z. And uh, a key challenge is to identify the point where we can have failures in order to initiate the process that I called migration. In this kind of problem, you may have two kind of approaches. One approach you can use a kind of reactive. Reactive, that means for some reason the instance, the edge device fails, or you can have a kind of outage. For example, you may have a kind of power outage. In this case, you need to contact the orchestrator who has a kind of repository of the tasks that have been uploaded, and then you can fetch the task again, you can start the service. This is, or another approach, you can have a kind of preventive. In this case, you can use a kind of AI in machine learning, and you'll see later on we have used LSTM to do a kind of prediction. So a prediction that uh, an edge device is about to fail. So before the fail process starts, we can initiate the migration. So at the end of the day, this is first set of results when we demonstrate at some point that we can have, in this example, we have used moving average in order to stress basically the edge environment, and then you will see at some point we have three instances: green, red, and blue. So you will see at some point that the green instance has been stressed a lot. So at some point you will see the resources goes down because we have initiated the migration from green to blue. And this is something that is also initiated. So this figure clearly indicates the different migration process. So the first instance, we've got the migration from red to green, 1 to 2. Then at some point, the green gets stressed, and then you can have in the same time migrating uh, towards two destinations concurrently from